Now, when we talk about first ionization energy, first ionization energy simply means removing the energy that is required to remove the first electron from a neutral atom. That is first ionization energy. Now, second ionization energy is now the energy that is now required to remove the second electron from what? From a cation. You get now. Let's illustrate. We are given different options here. If you look at lithium now, first of all, let's look at the electronic configuration of lithium. Lithium is 1s2 and 2s1. Now, the first ionization energy of lithium is that you remove this first one. You are removing this first one. So it's now left with what? 1s2. Now remember, this 1s2 is you are breaking into a noble gas core. And for you to remove electron from a noble gas such as helium, neon, argon, and so on, is very, very difficult. Have a complete number of electrons in their shell. So the electrons, the shell is more stable. So for you to break into the core to remove it is not possible. It is very, very difficult. Very, very difficult. So the energy that you use to remove is so hard. That is why the second ionization, you are not trying to say that you want to remove, like now, this is a structure now. This is what? A typical example of helium. Now you want to remove this electron from here. This shell already is balanced. So you want to remove them. So the energy that is required is what? Is very, very high. Do you get that? So now the second ionization, you are trying to remove one electron to be what? 1s1. So it is very, very what? High. Therefore, our correct answer is what? Let's explore the other options. If you look at beryllium, beryllium has atomic number what? 4, and the electronic configuration of beryllium is 1s2, 2s2. That is what? That is 4. Now the first ionization energy is 1s2, 2s1. You have removed one here. You get that? Since you have removed one, it is easier for you to what? To remove this one. It will require what? A lesser energy, because you have removed the first one. The second one, you are removing this one. Remember, this one is the core of what? The noble gas. Let's explore this third one. Boron. Boron has atomic number what? 5. So its electronic configuration of what? 1s2, 2s2, and 2p1. Are you following? Now, if you are removing this one, you are removing this is the first ionization energy. The second one, you are now removing into what? Into 2s, which will now to require more energy, like the lithium, which will break into the core. Are you following? So this one, you are now removing one here. Do you get that? So it now be what? 2s1. That is for the second ionization energy. Let's go to the third one. Carbon. Carbon has atomic number what? 6, with electronic configuration of 1s2, 2s2, and 2p2. Do you get that? Now the first ionization energy, you are removing this one from here. So 1s2, 2s2, and 2p1. That is the first ionization energy. The second ionization energy, you are now removing the one of what? One of these p. So this one now you are removing, it does not involve the noble gas, which have to break into the core of it. So this one will be less. The energy that will be required will be what? Less, as to compare to this one, lithium, that will break into the noble gas core. Are you following? So our correct answer is what? Is, if you are not asked which one has the largest ionization energy, a largest ionization energy is the more electrons are added to the shell, the more closer the shell is to the what? To the nucleus. Therefore, the amount of energy that will require to remove it is more harder. Different energy. Let's look at the first one. This one, lithium has 1 in its atomos shell. Beryllium has 2 in its atomos shell. Carbon has what? Carbon has 3. Sorry. Boron has 3. 1, 2, 3. Carbon has what? 4. 1, 2, 3, 4. So now Since this one has less electron, it is easier for you to remove this one, because I told you that the more electron are much in a shell, the more it becomes so difficult for you to remove. Therefore, in the first ionization energy, this one, the amount of energy that will require to remove this one is lesser than this one. So ionization energy increases across the world, across the period. So as you go across the period, ionization energy increase. Why? Because the number of electron in each shell is more than when you are starting a shell like this one. Now this one is just one, so the energy that you use, the energy that you will be required to remove this one is lesser than energy that will require to remove this one in the first ionization energy. But in the case of second ionization energy, is totally different. If you find this video useful, do well to like this video, share, comment.